Well, hello everybody. It's Mr. Kinney again here. So this is going to be the odd questions, the second page of our review sheet, questions 17 through 33 odd. So let's get to it. We have an equation triangle here for density, and density is mass divided by volume. What's nice with this equation triangle here, if you cover up the V, which means volume is mass divided by density, or if you're looking for mass, cover up the M on the equation triangle, D times V. Or if you're given mass and volume, you can calculate density as mass divided by volume. So number 17, grams is a measure of mass. Should have put a comma there. Milliliters and cubic centimeter are a measure of volume. That's how much space it takes up. And then, let me zoom out here. And then grams per milliliter and grams per cubic centimeter are a measure of density. And density is a comparison of how massive you are compared to how much space you take up. Okay, so we have this question right here. We have, box has these dimensions. What's the box's volume? We want you to round the answer to 1 decimal place. On this test, there may be quite a bit of that. So what we need to do is we need to take this, so volume is equal to length times width times height if it's a rectangular prism. Is that what they call it? Rectangular, a rectangular prism, which basically means a rectangle that's like that. Anyway, length times width times height. So I'm going to go ahead and just enter those in the calculator, multiply those together, and we got 4.3 times 35.5 times 10.1. Okay, so now when I multiply that, I'm getting 1,541 point. Okay, so again with rounding, the decimal place is there. This 6 is going to make us round that 7 up to an 8. And since it was centimeter times centimeter times centimeter, centimeter cubed. Number 21. Let's see here. If you have a mass of 3.1 grams of aluminum, okay, we got the density there for aluminum, and that what those densities again tell you that if you have a cube, there's a cube that's 1 centimeter on a side. They're saying for aluminum, if you have this much aluminum, it's going to weigh 2.7 grams. If you have this much iron, it's going to weigh 7.9 grams, and if you have this much gold, it will be a whopping 19.3 grams. Anyway, the question goes on to say, calculate volumes. And on the test, you may get a question that'll give you just this and say, which one of these will take up the most space? Here's a way you can do it. Well, and hopefully you can think about it and just think, well, okay, if I have a gram of each of these, which one's going to be bigger? Well, the aluminum's going to be bigger because it's got a lower density, so 1 gram of it will take up more space. But let's solve it. Using our equation triangle, we're looking for volume, mass divided by density. So volume equals mass divided by density, and the mass is 3.1 grams of aluminum, and the density for aluminum is 2.7 grams per centimeter cubed. When you put a fraction in the denominator of another fraction, this cubic centimeter gets popped up to the top. The grams cancel out, and then you can get your answer there. This is for aluminum. For iron, volume is still the same thing, mass divided by density. And the mass is still 3.1 because we have the same mass of each sample. In fact, maybe I'll put Fe, that's the symbol for iron. So 3.1 grams of iron. Its density is 7.9 grams per centimeter cubed. And those cancel out. The centimeter cubed will come up there. And then lastly, to get the last one set up, volume of gold is going to be, we have 3.1 grams of gold. The symbol for gold is Au. And the density of gold is a whopping, it's not the most dense element, but it's one of the most dense, and it's grams per centimeter cubed. The grams can cancel out. So you can go ahead and do the math on these, but what you're going to find out when you do is that this is going to be the largest volume, this will be the smallest volume, and this will be, well, I'll do one of them because I did ask you in this one to round it to 2 decimal places to practice that. So let's get our 3.1 divided by 2.7 equals, okay, so we got 1.148. So we're going to the Oh, sorry, but you can't quite see it on there. There we go. Get that so you can see it. So this is, we're going to this decimal place. So what that means is this 8 is going to make this go up 1. So we're going to have 1.15 for our answer. 1.15 cubic centimeters. So when you work those out for the other ones, you're going to find out this will be the largest volume. And did I ask you to put these in order of increasing volume? So for the list here, gold will have the smallest volume, then iron, then aluminum will have the highest volume. You know, when you actually calculate those, I'm not going to do that. You can do that there. Number 23. Let's see, you have a mass of 7,000 grams. Whenever you see grams, I want you to think mass. We've got a density here, okay. Calculate the volume. Well, okay, once again, we're doing a volume, same as before, mass divided by density. So we got 7,000 grams divided by 0.3 grams per cubic centimeter. Now, it's interesting, when you divide a number by a decimal, it really ends up multiplying, making this one bigger. So when you're looking at this problem, you want to think of it and go, okay, I've got 7,000 here. I'm dividing by a decimal number. It's really going to be multiplying this one is how it works out. So this is going to become much bigger. So we expect to see a much bigger number. And the magic 7,000, make sure I don't enter the wrong thing in, times 0.3. Now look at what I recommend you all do on the test is after, when you do your calculations, always set up your work so you know what you did. And let's see, in this one here, the grams cancel out, so we have centimeters cubed. Then go on to the next question, and then maybe come back when you're done with it and double check your math. Just make sure you didn't, do a goof up where you accidentally went 0.3 divided by 7,000. That would be, not good for you. All right, number 25. If you have 300 milliliters, that's a volume of molten lava. Oh, I love that stuff. Okay, I haven't actually. I've seen it once. Okay, you don't care. With a mass of this. Okay, what is the density? Density is mass divided by volume. Again, there's our base equation. On the test, you will have the base equation, but it's going to be mass divided by volume. So we're going to put in and set it up in this format. Put your base equation, then substitute for mass, 300 milliliters. And don't get lazy. Always put in your units. Let me zoom in a little bit so we can see a little better. Don't skip the units. And oh, wait a minute. Yeah. Oh, I goofed up. Now look at, see, because I double check, I put the volume on the top. Oops. Hey, it happens to the best of us, and in my case, the most experienced. Okay, 1,050 grams, and then we've got 300 milliliters. Remember, a milliliter is the liquid version of a cubic centimeter. A milliliter and a cubic centimeter are the same volume. Now, when I look at this problem, I see 1,000 divided by 300. So I'm going to expect this to be bigger than 1. In fact, I'm thinking it's probably going to be close to 3 because it looks like 300 to go in there. Well, maybe it's going to be 2 point something, but anyway, bigger than 1. 1050 divided by 300 equals, okay, yeah, it was bigger than 1. I'm going to let you put the actual answer in there. Okay, I got 3.5. Okay, 3.5, okay, grams per milliliter. So that means whatever this, if I cut this much of the lava, I guess, and let it dry so it didn't burn me, it would weigh 3.5 grams for every cubic milliliter. Okay, now we got a conversion here. How many meters are in 60 centimeters? So we're looking for meters. With dimensional analysis, which is the fancy name for conversions, you always start with what's given, 60 centimeters. Now we have conversion charts, and on the test they'll be up here. So we need to find the centimeter-meter conversion, and do we have a centimeter-meter conversion up here? Here we go. 100 centimeters is 1 meter. I'm just going to write that over here on the side. 100 centimeters per 1 meter. And we've practiced that you can also write it as 1 meter over 100 centimeters. Now, when we go to multiply this, so this is, in fact, I'm just going to make this a fraction, 60 centimeters, I'm just going to put it over 1. Because dimensional analysis, conversions, you're really multiplying a bunch of fractions. So I'm just putting a 1 over that. So now when I multiply by the next fraction here, I want centimeters in the bottom, and I want meters on the top. And when I look at my values over here, centimeters is 100, meters is 1 meter, and these cancel out. Now on your scientific calculators, all you need to do is do 60, then you can hit the divide button. Now you can multiply by 1, but 60 times 1 is just 60. So 60 then divided by 100, and it'll get you your answer. And looking at this, I mean 60, it should be less than 1, and it was 0.6, and that's going to be meters. Don't forget to put the units in. Okay, for 29, convert 6 million milligrams into kilograms. Okay, now let's see. This may be a two-part step, but let's see what conversions we have on our conversion table. So let's see. We got to do grams to milligram. Let's see. On here, did I do? Okay. Now milligrams, milli. In fact, we're just going to work it out this way, okay? Because I'm not sure if we have it on the conversion table. A milligram, milli is a prefix. It means a thousandth. So for conversions, you're going to say 1 gram is equal to 1,000 milligrams. Now I think on this data table I may have, let's see, do we have that on here? Do we have grams and milligrams? I may have, oh, I left that off on there, so sorry. Well, let's just put, I'm just going to add that on there. So 1 gram equals 1,000 milligrams. We kind of had it here where 1,000 millimeters is 1 meter. Sorry about that, I wasn't meaning to trick you on there. So we've got that, and now we got to go, let's see, we got a gram to milligrams, and the next conversion we need is that kilo means times 1,000, milli means divided by 1,000, okay, 1 over 1,000. So we're going to say that 1,000 grams is 1 kilogram. Okay, so that's our conversion factors we need. So this is going to be a two-step conversion factor. So we're going to put, you know what? I'm going to do this in scientific. I'm just going to put 6.0 times 10, 1, 2, 3, 4, 5, 6. I'm just going to do that. That's my given milligrams, mg. And I'm going to multiply that by, let's see, I want to get milligrams to grams. Oh, look at here. It's already set up how I had it there, because if I turn this one into a fraction, okay, so there's our milligrams over 1. Milligrams will cancel, giving us grams. Oh, that just was good luck on my part. So, okay. So now what's going to happen is the milligrams will cancel and the milligrams cancel there. And then, now what I got to do is I've got to get grams converted to kilograms. So what I need here is, this one won't work because grams and kilograms won't cancel. So I'm just going to do the reciprocal of this. I'm going to say 1 kilogram is the same as 1,000 grams, which it is. Now the grams cancel out. So now in this problem, with your scientific calculators, if you're not sure how to do this, what you do is you go ahead and you enter in 6. Now I'm using the EE button. EE, when you push it, or exponent or engineering, means times 10 to the, and then it leaves you a spot here, and I need to make it 10 to the 6. Now you could have just entered in the 6 million if you wanted to, but now with the scientific calculator, I've entered this in. I'm just going to do divided by 1,000, because I could do times 1, but then I still have to divide by 1,000. So divide 1,000. Now, when I hit the next button here, now we got to divide by 100, or excuse me, we got to divide by 1,000 again. So I'm just going to hit the divide button again, and now it's already done this part of the calculation for me. Now when I hit divided by, and we're going to do 1,000 again. You don't need to like write 6 million on the top and then 1 million on the bottom, equals, and the answer equals 6. And that's going to be 6 kilograms. Okay, and it kind of makes sense, because if you got a 6 followed by 6 zeros, here's 3 zeros, here's 3 zeros, those 6 zeros get canceled out by there, and the answer is just going to be 6. Okay, how many pounds is this? So our given now is 6 kilograms, so that becomes our given for this problem. And the kilograms to pounds, let's see what the conversion is. Hopefully, do we have kilograms to pound? There we go. 1 kilogram is 2.2 pounds. So let's see, we're right here. I'm just going to put off to the side. 1 kilogram is the same as 2.2 lbs. I'll put lb, for some reason, is the symbol for pounds. I don't know, it's a British thing. So, I love the Brits, okay. So, here's what our given, and I'm just going to turn that in, there we go, 6 kilograms, and we're going to multiply that We want kilograms down here in the denominator, and then we want pounds on the top. And then when we look over here, 2.2 pounds, and that's 1 kilogram. The kilograms cancel out, and 6.2.2 I think is going to be like, what is it going to be, like 13 point something, I don't know. It's going to be, oh yeah, okay, 6 times 2.2 is 13 point something, yeah, so 13.2 pounds. There we go. All right, the penultimate problem, that means second to last, fancy one. How many milliliters are in a 60-ounce soda? Uh-oh. So, milliliters, we're looking for milliliters, and we're starting with 60 ounces, 60-ounce soda. Okay, so we've got to go from ounces to milliliters. Let's look on our chart over here. So I'm looking for ounces. Okay, here's an ounce. Oh, here we go. Right, perfect, great. One nice little conversion right there. 1 ounce is 29.57 milliliters. 29.57 milliliters is 1 ounce. Now I'm going to double check that. 29.57. Make sure I didn't write it wrong. It's 1 ounce. Okay. So that's pretty cool. That's just a straight conversion. So I'm just going to put that over 1 because conversions, dimensional analysis really are just a series of multiplying fractions. And let's see, we want ounce on the bottom. Oh, just how we had this one set up is just how we need it, because we need ounces down here, so they cancel, ending up with milliliters. That's 1 ounce, and we have 29.57. So your answer is going to be 60 times 29.57. 29 point, let me make sure I get clear on this. 29.57 times 60, and it's like 17,000 and something, so. And that's milliliters per ounce, because the ounce, oh, excuse me, the ounces cancel out, it's just milliliters, which makes sense. Our soda is good for you. Water's the best thing for you. Water is best. You do need a few electrolytes, especially if you've been like sweating a lot. So, lastly, if it takes you 10 minutes to walk 1.5 kilometers, okay, so how fast is this in kilometers per hour? Well, I'm just going to do number 13 here, so 33, I mean. So let's see what we're given. How fast is this in kilometers per hour? We're given, oh, I guess we got to work it out. So 10 minutes to walk 15 kilometers. How fast is this in kilometers per minute? Well, that's going to be 1.5 kilometers per 10 minutes. Okay, that's what they're given to us. So let's see when we divide that out on there. So let's see, 1.5 divided by 10. Now, hopefully you know that, okay, you divide that by 10, it's going to get a little bit smaller, and it's going to be 0.15 kilometers per minute. Okay, so now there's the answer to number 32. Now the question is saying, how fast is this in kilometers per hour? Well, I'm going to make this the given of our problem. In fact, I'm just going to leave it right there. Okay, there's one answer. So we got 0.15 kilometers per minute. We need to convert it to hours. So I'm just going to make this now my first step in my conversion factor. Let me zoom in here a little bit. And we want to, let's see, I'm going to go like this. And we want to change minutes into hours. And let's see, we know that there are 60 minutes in 1 hour, so I'm going to put 60 minutes. Okay, and now the reason I did that is because I want the minutes to cancel now in 1 hour. So now the minutes will cancel out. And now you take that answer you had before, we're going to multiply it by 60. And that equals 9 kilometers per hour. So, oh, let's just do one more because they're so fun. They're so fun. How fast is this in miles per hour? Okay, we've got, well, I'm just going to start. We've got 9 kilometers per hour. Now we just want to convert kilometers into hours here. So I'm just going to say, okay, this is my first step in my conversion. We're going to leave it as hours. So let's see what the conversion is for kilometers to miles. And right there, 1.61 kilometers is 1 mile. 1.61 kilometers per 1 mile. So, oh, let me zoom out. Couldn't see that. So I just wrote that off to the side. You may have to do that on the test because all those conversions will be on the first page. So how fast is this? Well, we got 9, okay, I'll just rewrite, 9 kilometers per hour. Now actually, when we do that, I did that wrong. 9 kilometers over 1 hour. Okay, we're just going to get that set up like that, so it's already a fraction for us. So there's our given, and I've got it already set up as a fraction. So we want to get rid of, we're keeping kilometers, we want to get rid of the hour here, okay? So, oh wait a minute, my mistake, we're getting rid of the kilometers. So, sorry, it's an early morning. So I want kilometers down here, so these can cancel, and then I want, this is, oh, I see what I did wrong, that's hour up there. No, oh, I'm such a dork. That's per mile. Please forgive me for getting that wrong. Wow. Okay, I'm going to go get a cup of coffee after this. So I'm going to abbreviate, there we go, mile. So we have 1.61 kilometers for every 1 mile. So now the kilometers cancel, and we've got our 9 from before on the calculator, and we're going to divide it by 1.61, and our answer is 5. Now we're always going to round to 1 decimal place unless we tell you over. So that 5 gets bumped to a 6, 5.6. And we've got now, let's see here, miles. Okay, that's in the top still, good. And then we still have hours down there. All right, everybody, thank you for your attention. Hope this helps. Signing off. Just trying to stop it. Stop!